sketch the graph of the polynomial function p of x equals x plus 2 times x minus 1 times x minus 3. The first thing we want here is our end behavior, which we get by looking at the leading coefficient first, which tells us what the right side of the graph does. So our leading coefficient here, it's in factored form, so to get our leading coefficient we just multiply these x terms and see what we would end up with. And here we just have x times x times x, which is x cubed, which has a leading coefficient of 1. And that's positive, which tells us that our right side of the graph goes up. So y approaches infinity as x approaches infinity. And we look at the degree, and for the degree, well, we just multiply how many x's we have. We've got an x here times an x here times an x here, which is x cubed, so the degree is 3. And that is an odd number, and an odd degree tells us that the left side of the graph does something different than the right side. So here the right side went up, and so our left side will go down. So y goes to negative infinity as x approaches negative infinity, which means on the left. Then we're already in factored form, so we can get our zeros. So we look at each of our factors here. So we've got x plus 2, and solving that, setting that equal to 0, I get x equals negative 2. And that has a multiplicity of 1 because the exponent on that is a 1. And then I look at my next factor, which is x minus 1, and set that equal to 0, and we get x equals 1. And that also has a multiplicity of 1 because the exponent is 1. And finally, my last factor is x minus 3. So if I set that equal to 0 and solve for x, I get x equals 3. And once again, we have a multiplicity of 1 because the exponent is 1. So with a multiplicity of 1, that means that the way our graph touches the axis there is the way a line would. Okay? And it's for each one of these because a multiplicity of 1 is like x to the 1, which is a line. So we can draw our end behavior, which is that we're going up on the right and down on the left. And then we draw our zeros. So I've got at, let's see, negative 2, negative 1, up through 3 where I've got my zeros. So I've got at negative 2, I've got a 0. And at 1, I've got a 0. And at 3, I've got a 0. And then we just connect from our end behaviors to the those zeros, crossing like a line. So we come up, just cross like a line would, cross like a line would, cross like a line would. Okay, and that's a sketch of what our polynomial would look like.